So we have been so far talking about generic data types, and we have seen how to define classes, and we could have defined also interfaces the same way that have actually this generic property. Now what we are going to talk about is trying to stretch a little bit what we have covered so far and go beyond those basic examples. So let's take a look at what I'm referring to here. So, for example, here's a little interface. Okay, it's a generic interface. You can see the type parameters here highlighted in yellow. Okay, but the distinction between this example and the examples that we have covered so far is that we have two different type parameter noted k and v in this example. Okay, so this is just there to show you that what is possible, how we can extend actually based on the examples that we previously considered and do things a little bit more elaborate. So for example, here we have a pair interface, okay, which is supposed to represent a key value pair like you would find in a hash table, for instance. And you can see that we allow actually two different types to parameterize this generic interface, okay. So the K obviously stands for the data type of the key, and the V for the data type of the value. So we assume that we are going to be able to store inside objects that implement the interface pair, that we're going to be able to store those pairs of value K and V of those respective data type. And to be actually considered a pair, you have to implement those two methods that we see here in the interface. One that is getKey, and returns a data type K, and one that is getValue that returns a data type V. So we have two getters, two accessors for the K and V data types that are stored in an object of a class that implements the interface pair. So let's take a deeper look. So we have this interface pair. Now what we're going to do is we're going to implement it. So we have here a class, ordered pair. So the class is also a generic class. It's parameterized by the two same data types, K and V, and it implements the interface pair of K and V. So you can see how here, as we define this class actually that is implementing our interface, we are going to not specify what K and V are. We are going to receive them as type parameters from the programmers that are creating object of our class ordered pair, and we are passing them pretty much to the interface, the generic interface that we are implementing. Okay, so we take type parameters, we use them immediately. But we could have more than two type parameter here for ordered paired, right? We have K and V because we need K and V to pass them to the pair interface, generic interface, but we could have extra more type parameter here that we are using only in the implementation of this ordered pair class. So let's take a look at the code for that class. So we have two private attributes, two private fields. You would expect that, okay, since the ID is to store a pair of key and value. So the key attribute is defined as data type K, the value attribute is defined as data type V, nothing really fancy there. We have a constructor. Constructor takes two parameters named key and value, so the same name as the attributes. So we use the des keyword, you know, the implicit parameter here to disambiguate what we are trying to write here. So we want to assign the key attribute of this object with the key parameter that was passed to the constructor. Same thing for value. Okay, and obviously, well, the data type of key, we are going to use K to represent it. The data type of value, we are going to use V to represent it. Okay, that's the goal of this. And then we implement our two getters, okay, our two accessors. So getKey, getValue, trivial stuff, return the value of the attribute key, return the value of the attribute value. All right, so this is a basic example of having a generic interface and having a generic class implement that generic interface, and both of them feature multiple type parameters. So let's take a look now at how we are going to use those type of generic types. So we have here an example in which we define here a variable p1 that is of reference data type. It's meant to hold a reference to an object of class pair of string, comma, integer. P1 is then assigned a reference of a newly created object. So we call the constructor here, new keyword, ordered pairs, the name of the constructor. And then we have this notation here to specify actually, notation that you have seen in the past to specify actually the formal type parameters, the actual type parameters. And you can see that we just use the same comma separated notation if we have multiple type parameters. And then in between parentheses, you know, the arguments to the constructor, which the first one is a string, second one is an integer, so everything seems to be working. And then we have similarly P2, so same kind of deal, except that this is going to be now a reference to an object of class pair of string, string, and therefore we create a new object of class ordered paired of string, string, and we pass two strings to the constructor. Now, there is something that I kind of glossed over real fast on this slide. There is something that is not really working as it should. Okay, so what is this? Well, take a look here. We have defined here that we have a ordered pair of string and integer, but we are passing as parameter a string. And I said when I was reading this line that we pass an integer. But really what we are passing here is an int, okay? So primitive data type, reference data type, a reference to an object of class string, that doesn't really fit what we have here. Here we have, as with every generic, you know, generic type that we have been studying so far, we cannot have here primitive data types. We have to have reference data types, so class names in other terms, okay? Or over generic types as we're going to see. But here, there is a definite clash. Well, it's still working, actually. It's still working, but I want to make sure everybody understands why it is working, okay? So here we have a string, and it matches the actual type parameter, no problem. Here, we have actually int parameter, primitive data type. It's not matching the actual type parameter. So this is our problem, okay? I already covered this. So why is it working? Well, it's working because of something called autoboxing. Okay, so you have heard of autoboxing. You should be already familiar with autoboxing. I just want to remind you that it's going to be allowing you actually to pass values that are primitive data type, even in those cases where we need to match actually type parameters, okay? You have already seen autoboxing working when you have to match the type of a parameter in a regular method. So you have a method that accepts an integer. If you call that method, and instead of passing an integer object as parameter, you pass a value that is a literal int, it's going to work, okay? There's going to be autoboxing kicking in. Well, autoboxing kicks in also in this kind of scenario. So the 8 that you have here is pretty much replaced by something in the lines of integer.value of 8. So if you would have written integers.value of 8 instead of 8, it would be exactly the same thing happening, okay? It's just that Java is capable to do that kind of conversion automatically for you. So value of is a static method of the class integer, so we call it directly on the class, and it's going to take a primitive value of type int, and it's going to return actually a reference to an object of class integer. So that's what autoboxing is all about. So that was the first thing we needed to take a look at. Okay, now let's look at something else here. We mentioned that briefly over the previous slide, but let's make a point, you know, to consider an example here. When I have an ordered pair of string and let's say string, they can define it as a variable, reference variable P. And then I create an object of that same data type. So here I'm using the diamond operator to not have to repeat what I put here, okay? I will pass parameter to my constructor that are obviously matching the data types I mentioned here. So primes here is a string, match the first. But the second data type here, the second type parameter, right now I've been using things like integer, string, etc. And these are all fine, but they could be also more complicated. It could be a parameterized type themselves. So what would that look like? That would look like something like this. okay? So you have here an ordered pair. The first type parameter is a very basic reference type string. The second one is itself a parameterized type, okay? It's box of integer, so that refers to our previous example that we have been playing with for a little while, like the box example, okay? So we have a box of integer type parameter here, which is itself actually a parameterized type. So when you are creating your object, the same rules apply, right? Your first argument is going to match the first type, okay, because that's how the constructor was defined. The key comes first and the value comes second. And then the second argument is going to have to be something of this data type, box of integer. So in this example, we create on the fly a new box of integer object, and there are suspension marks, where the parameters of the constructor should go. But the idea is really that you just have to match the type. Now, those examples, they might have led you to believe that, if you have ordered paired string and box of integer, then that actually dictates the order of the parameter. And the reason you might be thinking that is that because in every single of our examples, the order of the parameters for the constructor was the same as the data types, that were provided here in the type parameter. But this doesn't have to be the case. If I go back a few slides, I'm going to rewind a bit the presentation. A little bit more. There we go. We are back at the beginning, when we define ordered paired. Well, this is where you define the order of the type parameter. So we know that the data type for the key comes first, it's named k. The data type for the value comes next. And then it just so happens that when we define the constructor, we put the parameter that's supposed to hold the key first. So it was of data type k, which was also first in the type parameter list here. And then v came second. But you could have a different order here, no problem. Okay, so that's pretty much, I'm going to go back to the end of the presentation. That's pretty much all we had to cover here to wrap up the part of our lecture that is actually on generic data types. So we are done with our overview of generic data types. Now we are going to turn our attention to the second Java construct in which we can introduce genericity, which is generic methods.